Okay, hi girls. I'm going to do two today. I'm going to do 2015 and 2013. So let's just have a look at 2015 first of all. We've got question 10. We've got two cars starting from rest and they begin to travel in the same direction. The speeds of the cars are given by VA is t squared and VB is 6t minus a half t squared. They're measured in meters per second and time is in seconds. You've got to find the speed of each car after 4 seconds. Okay, so straightforward for a start. So I have VA and VB here written down already. So I'll find the velocity of A when t is 4. So this, of course, will just become VA is 4 squared. So that's going to be 16 meters per second. And this one, VB, will be 6 by 4 minus a half by 4 squared. And when I work that out, I get 24 minus 8, and that's going to be 16 meters per second. So after 4 seconds, they both have the same speed. That's the first part. Now, the second part of the question says, find the distance between the cars after 4 seconds. Right, distance between them. So part 2, that was part 1, this is part 2. Distance between the cars. So let's have a look at that. So we know their velocity. Now, the VA is t squared and the VB is 6t minus a half t squared. So we're going to use these to tell us the distance that each has gone in 4 seconds, and then we'll find the distance between them. Remember, acceleration is not constant, so the only way we can get distance from here, from this velocity, is of course to use integration. So I'm going to change this velocity, v into ds dt. ds dt is equal to t squared. I'll separate the variables and then I'll integrate to find the value of the value of s after 4 seconds. So when I integrate that, I just get s equals ds equals s, and when I integrate the t squared, I'll get t cubed over 3. Okay, so I'll put in 4 seconds for t, which gives me an s of 64 over 3. Okay, so that's that part. Now let's do the same for VB. We'll change this, of course, to a ds dt. So ds dt is equal to 6t minus a half t squared. We'll separate the variables. ds is equal to 6t minus a half t squared dt. We'll integrate both sides. So this will become s equals, that will become 6t squared over 2. And this one will become minus a half by t cubed over 3. So this is therefore 3t squared minus t cubed over 6. Okay, I'll put in t is equal to 4 to find the corresponding s. So in this case, s will be equal to, when I put in 3 squared here, that's going to be 16 3s are 48, minus, that's going to give me t cubed is, when t is 4, that's going to be 32 over 3. Altogether, then when I subtract those, I'm going to get 112 over 3. Right, the distance between them then, the SAB, is going to be 64 over 3 minus 112 over 3, which of course gives me 16. So the distance between them, 16 meters. Okay, the third part. On the same speed-time graph, sketch the speed of A and the speed of B for the first 4 seconds. Shade in the area that represents the distance between them after 4 seconds. Right, so it's just a sketch for this part. So I'll get an axis. I'm going to sketch in the speeds. The velocity will be up the y-axis because that's changing in meters per second. Don't forget to label the axis. The time along the x-axis, of course, would be in seconds. Okay, so in order to plot a graph, I need some points. So I'll first of all do VA. So VA, of course, is t squared. So I'm going to find 4 points, velocity and time for VA over the first 4 seconds. So everything starts from rest at time 0. So these two cars start from rest, so this is at 0. So I'm going to do 4 seconds, 1, 2, 3, 4. Fill in the corresponding velocity. So this will be 1 squared, 2 squared, 3 squared, and 4 squared. And I'll plot those points. Okay, so my x-axis is just going to go from 0 to 4. 1, 2, 3, 4. My y-axis is going to go up to 16. So I'll go 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. Okay, at rest, time is 0, of course, so 0, 0. Then I'm going to go 1, 1, 2, 4, 3, 9, and 4, 16. So I've got more or less a straight line. I haven't got a ruler and I haven't got a graph, so I'm just going to do it like that. So this is it, about that, roughly. I'm a bit off, but you know what I'm trying to do. I'll do the same now for VB. So VB is 6t minus a half t squared. Time again for the first 4 seconds, 0, 1, 2, 3, 4. So I'll find the corresponding velocities. So that will be, starts from rest. VB when t is 1 will give me 6 minus a half, which of course will be 5.5. When t is 2, this will be 6 2 to 12 minus 2, which is 10. When t is 3, this is going to be 18 minus 4.5, it's going to give me 13.5. And when t is 4, I already know that's 16. So I'll now plot these corresponding points. So 0, 0 again. When t is 1, I'm going to 5.5. When t is 2, I'm going to 10 up here. When t is 3, I'm going to 13.5. And when t is 4, I'm up to 16. So this is, it's more of a curve, this one. Okay. Right, so I've plotted the points and now I've got to shade in the area that represents the distance between them. Okay, so this black line here, the area under that black line there would be the distance that A travels, and the area under the blue line would be, all of that would be the distance that B travels. So the distance between them would be, subtract the two, subtract the entire area under the blue line from the entire area under the black line, and I'll just shade that in there in red. So this bit here is the distance between them. This is your SAB. Right, that was kind of an unusual question for that section, but the important part here was realising that we had to integrate in order to get distance. Okay, so let's look at part B. Again, this was kind of unusual as well. It says a company uses a cost function CX to estimate the cost of producing X items. The cost function is given by this equation here, where F is the estimate of fixed costs and V is the estimate of variable costs. And we're told that dc dx is the marginal cost. Okay, so I'm just going to get into this page and put in another one here. Excuse me now for a moment. All right. Now, what am I told then? So I'm told that dc dx is equal to mx. Okay. It says a certain company has a marginal cost function given by the m of x is 74 plus 1.1x plus 0.03x squared. Okay, so mx is given as 74 plus 1.1x plus 0.03x squared. Now find the cost function. Okay, so I can see if dc dx is equal to mx, then this is telling me that dc is equal to mx dx if I separate the variables. And then if I integrate both sides, this will become c is equal to the integral of the mx dx. Okay, and I know what the mx dx is, it's this. So this is therefore telling me that c is equal to the integral of 74 plus 1.1x plus 0.03x squared. So I'm going to integrate this side here to get my cost function. Okay, so because remember C is the mx, is this integrated. So what will this become? So this cost function therefore will become 74x plus 1.1x cubed. Sorry, that's not an x squared, that's just an x. I've taken that down wrong from there. So this is 74 plus 1.1x plus 0. Yeah. So this becomes 1.1, when I integrate it, it becomes 1.1x squared over 2 plus 0.03 x cubed over 3. So that means my cost function, if I tidy it up, that will become 74x plus 0.55x squared plus 0.01 x cubed. Okay, so that's the first part. That's the cost function. Now the second part of the question says, find the increase in cost if the company decides to produce 160 items instead of 120. Okay, so if X would be the number of items, of course, that are made. So if I apply this equation here that I've got for the cost function and use variables, what I'll do is I'll get the cost of 74x plus 0.55x squared plus 0.01x cubed, but I'll put in variables from 100, or limits rather, from 160 down to 120. So what will my cost function be? So here it is. It's going to be 74 times 160 plus 0.55 by 160 squared plus 0.01 by 160 cubed. And from that I will subtract 74 times 120 plus 0.55 by 120 squared plus 0.01 by 120 cubed. Okay, so when I put that first bracket into the calculator, this entire part here is 66880. And when I put the second bracket into the calculator, this is 34080. And then when I subtract them, I'll get 32800. So this is the increase in cost if the company decides to produce an extra 40 items. So 32,800 is your increase in cost. So the last part of the question, girls, is it says if the C of 10 is 3550, find the fixed costs. Okay, so we're told that the C of 10 is equal to 3550. Now, if you come back to the beginning of the question, it tells you that the C of X items is F plus the V of X. So the C of X is equal to V plus the F of X, where, sorry, that's the other way round. The C of X is equal to, F plus the V of X. Where F are the fixed costs and V are the variable costs. Okay, so let's have a look. We'll find out what these variable costs are. Now remember, we know what the cost function is. We're after already finding that. So your cost function is 74x plus 0.55x squared plus 0.01x cubed. So let's put that in. That would be your variable costs. Okay, your variable costs. So for 10 items, so when X is 10, what will that become? So this will be 74 times 10 plus 0.55 times 100, 10 squared plus 0.01 times 10 cubed, which is 1000, and that will give me 805 when I put that into the calculator. Okay, so the C10 is 3500. Sorry, 3500. So C10 is equal to the F plus the V of 10. Now I know what the V of 10 is, that's 805. So this I'm told is 3500 Am I right there? 3500 is equal to the fixed costs plus the 805, which means that your fixed costs, when you subtract them, are 2695. So that's the last part of the question. Okay.